The total length of this video is about 123 minutes. Take you to a deeper understanding of the origin of the universe. Why did the universe come into being from nothing? Does the creator of the universe exist? Who created the creator? After watching this video, I hope you'll be happy with our universe. Have a deeper understanding. This is what Stephen Hawking said in a documentary. If you ask me if there's a God. So, if your so-called God is in the shape of a person, well, I think not. If you ask if there's a creator, well, I think there is. Because the entire structure of this world is not accidental. Hawking is one of the most legendary scientists in theoretical physics. His remarks were undoubtedly shocking. Ancient people sitting around the fire, closely dependent. The night sky is infinite, like a canopy full of stars. An elder points to the sky. Others then looked up, watching the shapes he drew in the air. For these early humans, the sky is more than just empty space. It is an existence full of unknown laws. They used the most original way, raised a question that spans thousands of years. What is the origin of all this? Mainstream science today believes the universe originated from an initial state of extremely high density and temperature. That is the expansion of space and time described by the Big Bang Theory. But who caused this explosion? A human being with 30 trillion cells. How was it formed? That wise brain and beating heart. What kind of miracles did they create together? How are natural phenomena, such as the sun, moon, animals, and plants formed? On the origin of the universe. Different cultures and scientific systems. Various explanations have been proposed. There's a hypothesis. Think. The birth of the universe may be created by a creator. But what is this creator? Jae-woo. Can we find any signs of its existence in the universe? The question that follows is, if there is a creator, whether as an individual miracle or a universal principle, where did he come from? Who created him? Is he from some greater power? Or does it exist forever beyond the law of cause and effect? For hundreds of years, humanity continues to seek answers from theology and science. We look for traces of the creator in classical literature, also in the deep universe, seeking the unreachable truth. Whether it is building a research institute or launch a telescope, all in pursuit of the eternal answer. Perhaps the answer lies in the universe itself. Those strange phenomena, like a black hole dark matter explosion. Is it revealing to us the origin of existence? On the journey to explore the origin of the universe, are we being led to the edge of the universe, even further into the unknown? If we really find traces of the creator, what will that look like? Georges Lemaitre's early life, full of a restrained and firm ambition. In Belgium, he grew up in a society that was deeply interested in science. In the context of the increasingly obsessed era, Lemaitre studied at the University of Louvain, passionate about scientific exploration. He believes studying the universe is a process of revealing the laws of nature. He firmly believed that no matter how the truth is revealed, the ultimate law is unity. For him, explore the universe. It is a reverence and exploration of the order of the universe. It is worth noting that he is passionate about scientific exploration. In the process of exploring the mysteries of the universe, always maintain a profound spirit of thinking, willing to question and contemplate, never blindly accept ready-made answers. In that era, Lemaitre wanders in the ancient, between the spiritual realm and the scientific world, in the history of science, on the theories of Galileo and Copernicus. It has led to a re-examination of the universe, reflects the dialogue and evolution of different ideological systems. But Lemaitre had a very different view. He believed that science was a way to understand reality, helping humans reveal the working mechanism of the universe. By exploring science, we not only understand the laws of nature, I also gained love and hope for life. His approach is delicate and thoughtful. Based on such a belief, one truth can illuminate another truth. Is this belief, push him, made one of the most profound scientific discoveries of the 20th century. Early 1920s. At that time, the universe was generally believed to be static and eternal. Many famous scientists believe the universe has neither beginning nor end, as if in a constant state. This steady-state universe, comforting to a certain extent, because it suggests a world without a creator. Like many scientists after the Enlightenment, secular views formed. Coincidentally, however, Lemaitre held a different view. After further study of cosmology, he began to pay attention to Einstein. General relativity reveals distortion of space-time structure in the equation. He saw possibilities that others overlooked. The universe may not be static. It is in dynamic expansion. If established, then the universe must have been more compact in the past. It may even be condensed into a tiny point. His thoughts quickly led to a shocking conclusion. If the universe had a beginning, a moment, all space-time, energy, and matter all emerge from that infinitely dense point, then we can say that the universe has no yesterday. This is not just a scientific hypothesis. It also contains profound philosophical connotations. This theory describes the universe from an extremely high-density state, beginning the expansion process. Different accounts of the origin of the universe from earlier human accounts. An interesting contrast. At first, Lemaitre was cautious in his argument. I know this will lead to fierce questioning. In 1927, he published a paper, proposed that the universe is expanding. Its current state can be traced back to a single explosion. Although his work was groundbreaking, but it also encountered a lot of resistance. Even Einstein. At first, I refused to accept this view. He is said to have said to Lemaitre, "Your calculation is correct, but your physics sucks." This resistance is not surprising, because the concept of a finite beginning of the universe is accepted. Providing space for philosophical discussion challenges the scientific assumptions of the traditional steady-state universe. But Lemaitre never gave up. He continued to improve his theory, gathering more evidence, and over time, constructed a mathematical model to support his point of view. With the new observations, gradually verified the concept of cosmic expansion. The scientific community's view of him also began to change. 1929. American astronomer Edwin Hubble's observations. Galaxies generally move away from each other. Provides empirical evidence that the universe is expanding. This laid a solid foundation for Lemaitre's theory. Ironically, the term Big Bang, originally written by astronomer Fred Hoyle's ironic suggestion, he has always firmly opposed this theory. However, as more and more evidence supports this view, the name and theory eventually survived. In the mid-20th century, become the mainstream model to explain the origin of the universe. For Lemaitre, this is not only a huge breakthrough in science, it also verifies his scientific and philosophical beliefs that can complement each other. He did not try to use the Big Bang, prove the necessity of some ultimate existence. Rather, we see it as a way to understand the evolution of the universe. He is cautious. Keep the boundary between scientific research and philosophical speculation clear. But his discovery deepened his exploration of the origin of the universe. Belief, promoting his continued research in the fields of science and philosophy. Lemaitre first proposed the theory of the expansion of the universe in 1927. About 40 years later, Stephen Hawking at Cambridge University completed PhD research on the origins of the universe. Since ancient times, this problem has been troubling countless scholars. Hermit, a 20th century cosmologist, its research prompted the scientific community to re-examine the origin of the universe. At the same time, it reflects the richness of the intersection of science and humanities. As for Hawking, his path of exploration, it went in a completely different direction, where he proposed the no-boundary model 20 years later. His view on the existence of origin, in sharp contrast to its predecessors. Hawking's personal experience is as good as his theory, full of complexity. In 1963, when he was only 21 years old, diagnosed with ALS. This is a doctor's opinion, a fatal disease that would give him only a few years to live. The fight against fate not only subverted his expectations, it has revolutionized our understanding of the universe. Hawking's theoretical model tend to start from the laws of nature, explaining the origin of the universe, arguing for the self-sufficiency of physical laws. His no-boundary theory, one of his most ambitious ideas, aims to explore fundamental questions about the origin of the universe. To understand this theory, we must delve into the structure of space and time. According to Einstein's general theory of relativity, gravity is more than just a force. It is the distortion of space and time caused by mass and energy. Under extreme conditions, such as approaching a black hole or at the moment of the Big Bang, this distortion will become so severe, so traditional physics no longer applies. Hawking's research on black holes. He also made significant contributions. He proved that black holes are not. It is dark, but radiates energy. This phenomenon is now known as Hawking radiation. The discovery triggered his further thoughts on the origin of the universe. Lemaitre once described, the universe began to expand from an extremely dense starting point. Hawking tried to find, can the universe avoid this starting point completely? In collaboration with James Hartley, Hawking proposed the no-boundary model. This is a quantum mechanics-based theory of construction. In this model, the universe did not begin at a single point. Instead, it started from a smooth and finite state. Imagine, as you head north, arriving at the North Pole. But the North Pole is not the edge or boundary of the Earth. It is just a place where the concept of north has lost its meaning. Also in Hawking's model, time at the origin of the universe, behaving like a spatial dimension. Backtracking does not hit boundaries or the beginning. Instead, it presents a smooth, curved geometric shape. Natural integration with space. Hawking uses the mathematical concept of imaginary time to explain this shift, treating time as a dimension similar to space. As he said, such a universe has no clear starting point. There is no end. Traditionally believed, the idea that the universe had a definite beginning is quite different. In A Brief History of Time, he described how the universe spontaneously emerged according to the laws of quantum mechanics. This concept, it profoundly influenced his understanding of the universe and the role of the creator. Hawking proposed in the framework of quantum gravity theory, the universe may have formed spontaneously through quantum fluctuations. Its boundary conditions are determined by the laws of physics. No external initial conditions required. He believed that it was the laws of nature, such as gravity, allowing the universe to spontaneously emerge from quantum fluctuations. For him, the beauty of the no-boundary hypothesis is that, in its self-sufficiency, he depicted a universe governed entirely by the laws of physics. These rules, natural and inevitable, based on the basic principles of quantum mechanics. However, not everyone fully accepts Hawking's hypothesis about the self-creation of the universe. Some people pointed out he relied on the laws of physics to explain the origin of the universe. But there is still a mystery left. Where do these rules come from? Why do they operate in such an orderly manner so that life can exist? If we compare the universe to a huge machine, even the most advanced machines, designers are also needed to set rules. From this perspective, Hawking's theory, it doesn't seem to be completely eliminated, the need for a deeper explanation, but just that layer of mystery, raised to a higher level. In 2010, Hawking proposed, quantum fluctuations may occur under no boundary conditions, promoting the spontaneous evolution of the universe. This bold claim, it has sparked widespread debate in scientific and philosophical circles. In Oxford University mathematician and philosopher of science John Lennox believes that Hawking's explanation still leaves some key questions unanswered. John Lemhust was born in Northern Ireland in 1943, when Lemhust came into contact with Hawking's universe. When you can create your own arguments, he believes this argument goes beyond the scope of traditional philosophy, deeply touches on the fundamental issues of logic. Hawking argues that the laws of physics, especially gravity, capable of causing the universe to spontaneously emerge from nothing. But in Leibniz's view, this assertion is self-contradictory. If the universe really was nothing before creation, then the laws of physics themselves, it already presupposes a certain existence, rather than absolute nothingness. Lennox pointed out, laws do not exist in isolation. They are just used to describe, need to rely on physical foundation, the process of making it work. For example, law of gravitation. It can explain the interaction of mass and space. But if there is no matter and space-time as the foundation, gravity loses its meaning. He believes explanation of the laws of physics as the cause of the universe. Just like claiming that an aircraft has no manufacturer, existing out of thin air. These laws only apply under certain conditions, describing how things change. It does not generate these conditions. For Hawking relies on quantum mechanics, explanation of the origin of the universe. Lennox also raised the question of, he believes that despite the borderlessness project, mathematically, this provides a clever solution, but he still relies on pre-existing quantum states governed by specific laws. Although this model avoids the emergence of traditional starting points, but it does not eliminate the dependence on initial conditions. In other words, explaining the origin of the universe with the help of quantum wave functions, it just postpones the problem. Why this wave function? What determines its specific form? In Lennox's opinion, Hawking's model does not touch on the deeper issues. That is, why there is existence rather than nothingness. He believes that this issue, it is actually an infinite regress problem. Explain the existence of the universe by natural laws alone. It seems that there is always a need to introduce a more basic law or framework. These need further exploration. If the universe originated from a quantum vacuum, you must ask how the physical laws governing the quantum vacuum emerge. If we regard these laws as vivid existence, its own origins still need explanation. Lennox believes this series of questions, it is not limited to the universe system. It points to a deeper level of scientific exploration. He draws on the philosophical argument of causality. In science and philosophy, a basic principle is that every effect must. There is a reason. Hawking argues that the universe may have a spontaneous origin, but in Lennox's view, this theory still needs further explanation. Source of initial conditions. This is an important topic in scientific exploration. Similarly, let the universe create itself. He must exist before he does not exist. This is obviously a logical contradiction. It's like trying to use your hair. Just like pulling myself out of the non-existent quagmire. Considering the true meaning of nothing. That does not exist. The absolute nothingness of any space, time, energy, or law. This problem is even more obvious. Absolute physical nothingness. Lack of conditions to trigger spontaneous events. Therefore, the hypothesis that the universe came from nothing is an illogical dilemma. This reasoning implies the necessity of external causes. Before the universe was formed, there must be some uncaused cause, something beyond the laws and limitations of our universe. Independent, fundamental reality. This hypothesis of a cause without a cause as the basis of existence. Ontological exploration from the perspective of classical philosophy. The necessary conditions for modern cosmology. The core controversy of the origin issue. This independent existence is unlike anything else. It needs no further explanation, only as the ultimate source of all existence. This view, challenging the view that the universe is self-sufficient and self-explanatory, suggesting that the universe is not a closed system. Rather, pointing to some initial conditions beyond existing cognition. The subtle operation of complex laws in nature. Precise control of physical constants. And we can observe these phenomena. It seems to be hinting. Some deeper reality that is not bound by time and space. This is the fundamental reason why space and time come into being. To further illustrate this point, let's think about the fine balance that makes the universe suitable for life, whether it is subatomic, particles, or the movement of huge galaxies. All follow the precisely regulated laws of nature. Any slight deviation could make the universe uninhabitable. For example, the gravitational constant determines the force of attraction between matter. If gravity is slightly stronger, the star will run out of fuel too quickly and collapse into a black hole. If the star is weaker, it cannot ignite. The universe will fall into eternal darkness. Similar to cold, the electromagnetic force governs the interactions between charged particles, directly affects molecular formation and chemical reactions. Fine-tuning of proton mass determines the nuclear reactions inside stars, thereby affects the production of basic elements of life, such as carbon and oxygen. Even the cosmological constant is extremely precise. If it expands too quickly, matter dispersed before it could gather into galaxies. If the expansion is too slow, the universe will collapse back into itself. All these constants, they are in a very delicate balance. It's as if the universe is sitting on a knife's edge. Delicate control to allow the emergence of complex structures and even life. Another impressive example. It is the great effect of the strong nuclear force. This effect, the protons and neutrons in the nucleus, closely integrated. If this force is weaker, the nucleus cannot remain stable. Hydrogen may be the only element left in the universe. On the contrary, if it is slightly stronger, the star will consume its nuclear fuel too quickly. The possibility of life existing will also be destroyed. These peculiar combinations of physical constants raise questions. Universe parameters that support life. Why is it in the critical range? This irreconcilable coincidence. It is the so-called fine-tuning problem. For decades, it has always fascinated physicists and philosophers. Some scientists, such as Max Tegmark, have proposed, perhaps, our universe is just one of many. Each universe has its own laws and constants. However, the multiverse hypothesis, it is a scientific study of theory of tuning problem 1. Its verification depends on the progress of future observation technology, the complex structure and delicate balance of a universe. This has triggered diverse discussions on the origin of the problem in the scientific community, including the self-consistency of natural laws, quantum field theory hypothesis, etc. Sir Martin Lees, renowned astrophysicist, he believes that the emergence of life is not purely accidental. It is based on extremely specific conditions. Lees and other cosmologists consistently emphasize the fine structure of a universe cannot be explained by chance alone. More in-depth scientific exploration is needed. Paul Davies proposes that the laws of the universe may be transcendent. The underlying principle, he believed that the precise laws of nature may hint at some kind of organizing principle beyond the universe. This thinking highlights the universe's incredibly precise system of laws and the ability to create conditions for the evolution of life, all pointing to a fact that is not a coincidence, actually fine-tuning the problem. This has led to many hypotheses about the origin of the universe, including scientific models and philosophical thinking. As our understanding of the universe continues to deepen, it was found that even a small change in its constant, it will also make life cease to exist. This undoubtedly implies that the universe was created with a purpose. That is to say, special values of cosmological constants. It has triggered scientific discussions on the mechanism of cosmic evolution, including the multiverse hypothesis, theoretical models such as the anthropocentric principle. These studies all are based on the self-consistency of natural laws. Francis Collins, the doctor and geneticist, former director of the National Institutes of Health, he is known for leading the Human Genome Project. In addition to his outstanding contributions to science, Collins has publicly discussed the intersection of science and humanities. Cross-emphasis, exploring the mysteries of the universe, requires a multidimensional perspective. He believes that the universe is finely regulated. It reflects the precision and complexity of natural laws. He had argued the structure of DNA and the complexity of life, and the delicate balance of cosmic physics. It's not a blind coincidence. Rather, it reflects the subtle regulation of natural laws. Scholars from Sir Roger Penrose to Alan Guth all recognized the extraordinary precision of the cosmological constant. For example, the possibility of existing. The universe is in such a finely tuned state. It cannot happen by chance alone. The delicate balance of physical constants in the universe. This has triggered an in-depth discussion of the origin of, for example, the multiverse hypothesis, or the self-consistency of natural laws. However, despite growing evidence supporting the creator, a puzzle remains. If the universe needs a creator, then who created the creator? This question goes to the heart of the matter. This question seems simple. This actually touches on the so-called infinite regress paradox, the core of the infinite regress problem, the applicability of the law of causality. One of the basic assumptions of scientific research. There is a causal relationship between phenomena. Is this chain of cause and effect? The motion of atoms is explained by, to the foundation of the universe. However, when this idea is applied to the origin of the universe, we are faced with an intractable dilemma. Imagine a simple pool table. Balls arranged in a row. You pick up a club. Hit the first ball hard. Then the power is passed on. Form a series of movements. Every action can be traced back to a previous cause, from hitting the ball to swinging the club. However, if someone asks what makes the club move, the answer is your arms are waving. And further question is, what makes your arms move? This leads to a deeper chain of cause and effect. Keep asking like this. We are trapped in an infinite regress. It's hard to find a final starting point. Applying this concept to the universe itself, if from the formation of stars to the evolution of all things, every phenomenon depends on its antecedents, then the source of the initial conditions becomes the core issue. According to the law of causality, everything must have an explanation. But if every reason all depend on another previous cause, so how do we find the original starting point? If you keep asking, it will eventually fall into an infinite loop. The first cause can never be found. The Big Bang Theory, often cited as evidence for the beginning of the universe. But it also raises a question. What triggered the Big Bang? What gave rise to the conditions for the Big Bang? And if the chain of cause and effect has no end, then this chain seems to have no real beginning. For some philosophical views, this paradox suggests, if some primordial force is the origin of all things, so what is the source of this power itself? Although this question seems logically reasonable, but also reflects, human thought transcends time and space. Limitations, in the process of searching for answers, begin to focus on the concept of necessity. This idea originated from classical philosophy, claim that not everything must have a cause. Most things in the universe exist by chance. A tree depends on sunlight, water, and soil. A planet depends on gravity and the laws of physics. But if everything is just accidental, that means there are some beings without solid foundations. In comparison, a necessary being is self-existent, not dependent on external factors. This is also the so-called cause without cause. To further explain the solution to the infinite regress problem, in the field of science, there are also some irreversible and the basic rules. For example, the laws of thermodynamics in physics describes the law of conservation of energy and the law of increasing quotient. These laws are considered the foundation of physical reality, cannot be derived from a deeper level. Similarly, the concepts of zero and infinity in mathematics, although it cannot be fully explained, but it is crucial to building a mathematical system. These examples show some basic truths. It may go beyond simple causal inference. Theory of infinite regress. It is usually assumed that there is an endless chain of time. Keep tracing back. But modern cosmology points out, time seems to have a starting point. Space and time were born in the Big Bang. If the time starts from the explosion, then the law of causality that we are familiar with, perhaps not for the state before the universe existed. This is consistent with the philosophy that the Creator exists beyond the dimension of time. The view that time and space are the origin of each other coincides. Combining these thoughts, the infinite regress paradox should not be seen as a flaw in logic. It is a window into the ultimate nature of reality. The question of who created the Creator seems natural, but he mistakenly identified the Creator, placed in the same causal framework as the universe. If the Creator forms the basis of the space-time framework, then ask the Creator for the cause. Loss of physical meaning. Like exploring events before the birth of time. Scientific exploration. Let us continue to reveal the laws of the universe. But about the ultimate origin, there are still many different theories. Some people think proposing a creator as the uncaused cause, actually avoiding the question, rather than actually solving the problem. Critics ask, Why the chain of cause and effect must end with the Creator. Why can't we assume that the universe itself is a necessary entity? Scottish Enlightenment philosopher David Hume. The local causal relationship observed has been questioned. Is it reasonable to generalize to the origin of the entire universe? Shio Mo pointed out, our understanding of causality comes only from experience. We have not directly experienced the process of universe creation. Therefore, any claim about its cause, including the existence of the Creator, there is inevitably some element of speculation. Hume's skepticism. This further shakes up the infinite regress paradox. Assumptions that causality is universal. From a scientific perspective, some theories attempt to use models that do not require base to resolve this paradox. For example, in quantum mechanics, there is an event, phenomenon that occurs without a specific cause. Some cosmological theories. The multiverse hypothesis. We believe that our universe, possibly a series of processes that do not rely on a single cause. Also, physicists and philosophers have also proposed that the universe is cyclical, or eternal model. Think, the universe operates in a constant cycle of expansion and contraction. No clear starting point is needed. These views, challenging the traditional philosophical interpretation of the causal paradox, suggesting that the universe itself may be eternal, self-sustaining properties. Another controversy is the universal principle of causality. It is based on the concepts of time and space. Under the extreme conditions of the origin of the universe, applicability of traditional causal relationships, still a topic of scientific research. This weakens the causal chain. Argument for the need for an ultimate explanation. All these arguments, all based on a key assumption. If there is an ultimate cause, the Creator should be considered as a personal, sex, and the existence of intelligence, similar to life as we understand it. However, if this assumption does not hold, the Creator or ultimate reality, maybe it's not a personality at all, is a more basic essence or law. Spinoza claimed. The universe is a self-consistent entity. Natural laws reflect their inherent regularity. For him, the essence of the universe is not some external force. It is a direct reflection of its own laws and structures, whether it's stars, planets, galaxies, or it rules gravity and electromagnetism. The natural law of the strong and the weak. They are all part of the essence of this universe. In other words, the universality of natural laws and the complexity of the universe. It inspired people to think deeply about the nature of existence. In this view, the Creator is not the first person of mankind. It is the eternal expression of the laws of nature. Gravity, thermodynamics, laws, quantum mechanics principles, and the properties of light. These are not just accidental rules. It's part of the origin of the universe. The universe operates according to these laws. Just like a beautiful work of art, it is composed of its inner order. Further, Spinoza's thought, it also profoundly affects our understanding of time, understanding of space and existence. Time is no longer a linear progression. It's part of the nature of the universe. It is the dimension in which all existence is interconnected. From the birth of stars to the rise and fall of civilizations, they all reflect the unfolding of a certain natural order, rather than random events. That's why our lives should not be seen as accidental. It's part of nature's grand plan. Human thought, behavior, and consciousness. All of these are closely related to the precise regulation of natural laws. By knowing these laws, we can have a deeper understanding. My place and significance in the universe. Spinoza's understanding of the universe. It gives existence a whole new meaning and sense of purpose. Since everything is a manifestation of the essence of nature, then every moment of existence is full of meaning. There is no need to look for another purpose outside the universe. Living itself reflects the existence of nature, human behavior, interrelated with the laws of the evolution of the universe. Scientific exploration revealed how the laws of nature shape the complexity of existence. The pursuit of knowledge. It also turns into a spiritual pursuit, studying the universe, exploring the laws of nature. Essentially, it is an interaction with the cosmic order that sustains the universe. Scientific exploration and star research, an understanding of the laws of physics, help humans gain a deeper understanding of the nature of the universe. As our understanding of the universe continues to deepen, our understanding of the nature of the universe is also increasing. Philosophy of science and spirituality are not separate pursuits, but to have a dialogue with the ultimate truth together. Multiple ways. The interconnectedness of everything in the universe. It also makes people humble. Since all existence, they're all part of the same cosmic essence. Then humans are not the center of the universe. It is just one part of a huge, tightly interconnected system. Our thoughts and existence, also subject to the same universal laws. And these laws govern everything else in the universe. From this perspective, we are not separate from nature, but integrated. Understanding nature should be established in, behind a rule, above the humility and awe of the cosmic order. Final. The universe reflects the natural laws that underpin everything. There is no separation between source and phenomenon, because everything is part of the same system. Natural laws, cosmic structure, and even particle behavior. It's the manifestation of the laws of nature. This law constitutes the basis of all things. Make the universe no longer a random combination of matter and energy. It is a world governed by the laws of reason, unified whole. As our understanding of these laws deepens, the truth about the origin of the universe will also be gradually revealed. Spinoza's thought. Not only is it revolutionary in content, its impact is also far-reaching. His opinion eliminates reliance on personal intervention from a source, exploring the natural world for science and philosophy, provides a new foundation. Spinoza's holistic philosophy, for scientists, providing a new perspective on understanding the laws of nature. For example, Einstein once quoted his ideas, explore the rational nature of the universe. But he made it clear, he admired, it is the source that reveals the order and harmony of existence. In fact, Einstein made it clear several times. Opposition to the concept of personal God. In a letter in 1929, he wrote that he believed in Spinoza. He revealed the existence, order, and harmony of self-expression. In 1954, to the philosopher Eric Gutkin's letter, he also bluntly stated that some classics were written by people, features of early cultural legends. Einstein's spiritual foundation, in awe of the order and rationality of the universe. This goes far beyond simple, abstract concepts based on personification. This view is also echoed by Carl Sagan, this famous astrophysicist and popularizer of science. His view of the universe, heavily influenced by the philosophies of Spinoza and Einstein. Sagan emphasized the systematic interconnectedness of the universe, the precision of natural laws, showing awesome order. In his groundbreaking series, using poetic language to express that the universe is within us. We are made of stars. We are the universe's way of understanding itself. For Sagan, the origin is not some entity. It is describes the way humans are deeply connected to the universe. The saying we are made of stars. This reflects a scientific fact. The elements we need. They are forged in the cores of stars. This cosmic legacy, the grand story of humanity and a vast universe. Connected, echoing Spinoza's view on the unity of all things. The idea of a permanent entity. Sagan's concept of self-awareness in the universe. It can be seen as an extension of Spinoza's thought, suggesting that through human consciousness, the universe gained a reflective understanding of one's own nature. This view, giving spiritual meaning to scientific exploration, the process of human exploration of the universe, as a manifestation of the universe's inner self-consciousness. Perhaps Lennox's argument, Spinoza's philosophical system, or Sagan's description of the poetic universe. These debates about the nature of the universe more reflects the diversity of human thinking, our interpretation of power and meaning. To a large extent, it is the human heart, a manifestation of the desire for belonging and understanding. In the process of exploring the origin, we are actually searching deep within, a truer self, that is the core and essence of our existence. As Carl Jung revealed, shadows dancing on the ceiling. Only those restless hearts are flickering to project the light. Jung was not only a scientist, a spiritual explorer. He wanders in an endless maze of his mind, raised an eternal question. Why do we always surpass ourselves? He believes the ideas we believe in and the true stories. It's not a random fiction. It reflects the deep archetypes rooted in the collective unconscious. These archetypes are not only active in our minds, shaping our vision, also in the subtle, influencing the way we search for meaning. Try to imagine a scene like this. You're standing on the edge of a vast ocean, rough waves in the distance, beyond the reach of the naked eye, under this vast expanse of water, hidden in the collective unconscious, vague and mysterious, ancient and deep. In Jung's view, this ocean is not without order. It has a fluid motion and a unique shape, and those archetypes hidden deep within, swimming like a whale. Although it is difficult to see, but cannot be ignored, they symbolize the rich foundation of human experience, such as mother heroes and even the existence of nature. Jung did not just sit in his armchair, weaving dreams with metaphors. His thoughts come from his own life experience, patience and struggle. Once a woman came to him, telling a recurring dream. In a dream, a brilliant and magical person handed him a golden cup. He woke up in a cold sweat, full of doubts. I don't know what this dream means. For Jung, the gold cup is more than just a prop in a dream. It is a symbol, a prototype. It may represent the pursuit of higher things, a deeper direction. The human heart longs to connect with a power beyond the self, the need for meaning in chaos. He believes these archetypes exist within everyone, but at the same time has a distinct personality. They are not just great ideas floating in the universe. It is closely connected to everyone's heart. When people dream about God or talk about, Jung did not see them as evidence for the existence of gods, but for inner needs, a manifestation of desire and the search for meaning. You may ask, does this mean that Jung believed that the Creator is unreal? Actually not. For Jung, the key is not, does the Creator exist as some objective entity? But it lies in the meaning contained in the Creator. He proposed natural phenomena may reflect archetypes in the collective unconscious. Imagery symbolizes the process of psychological integration. When people pray and meditate, or create stories about the Creator, they're actually pursuing inner integrity and order. I hope to find a story that makes life meaningful. Recalling our favorite stories, whether it's an old mythical superhero movie or an epic fantasy legend, they all share a common theme: the hero's journey. Heroes are often summoning a power more powerful than yourself, going through various tests, battle against a mysterious enemy, finally reborn. It's not just a narrative structure. It is a manifestation of a prototype. As we enjoy these stories, seeing more than just the heroic images on the screen, it resonates with those who are constantly searching for meaning through self-reflection, pursuing inner growth. In other words, the gods we created and worship. It is a mirror that reflects our inner self. It is also a map that guides us forward, tell us who we are, and lead us to become our ideal selves. So, what about the skeptical scientists? They may seek truth from equations and data. No need for divine intervention. But Jung would think the pursuit of meaning is a common human emotion. Even in the lab, we are exploring the truth. That thirst for knowledge and meaning. It also leads to the same conclusion as philosophical thinking. Whether under the starry sky or in rigorous data, our inner calling is the same. For Jung, the human soul, much more than electrical signals from neurons in the brain, is a self-contained microcosm, full of mystery and meaning. One of his most personal explorations. It is reflected in the Red Book. This huge illustrated manuscript records his dreams, visions, and inner reflections. In the book, he battled symbolic gods and demons. These images do not exist externally. It's part of his inner world. The process of creating a Red Book. He's essentially searching for meaning, a journey to connect the inner and outer worlds. From a broader perspective, the idea of harmony, challenging our definition of God and life. Maybe the God we created. It is not pointing to some literal magic. It could be a career, a relationship, or a belief. In short, everything we give lofty meaning to, they become our gods in some way. Just like the prototype, these miracles can guide us forward. It may also devour our souls. The point is not whether we created God, why we create, as well as what do these gods reveal about our inner truths? Through scientific philosophy and reflection on the inner world, we can see concept of God. In fact, it is discussing the fundamental questions that give life its richness. Is it the universe that created us? Or do we project our own spirit into the universe? Some philosophers and scientists believe that the relationship between the existence of the universe and consciousness, still a mystery, it reflects our understanding of the world, hope for the future, and the question of the eternal mystery of existence. For me, the Creator is more like a presence that can be felt, rather than an entity that must prove its objective existence. Humanity's exploration of the nature of the universe. It contains the revelation of scientific laws. It also covers diverse thinking in fields such as philosophy and art. For example, some philosophical systems emphasize the interconnection between all things. Understanding the nature of the universe requires both scientific evidence and philosophical thinking is also needed. For example, philosophical theories that explore the interconnectedness of everything. When we truly understand that I am not just flesh, more than just thinking, when I am part of the natural soul, we will discover the eternal supreme truth. It is already shown brightly in everyone's heart. Planets on stars. Even before the concept of time came into being. Where did it all come from? Try to imagine a moment of absolute nothingness. It's not just darkness or silence. It is a realm that transcends both, full as if nothingness can't be fully explained. But what does nothingness really mean? When space, time, and matter are completely absent, what kind of existence will there be? Perhaps it is in this mysterious state, planted the seeds for everything. Physicists call this state the quantum vacuum. It is different from the vacuum of space as we understand it. It has a more bizarre and profound connotation. The quantum vacuum is not a bathing ocean of particles. Rather, a realm without even the slightest sense of existence. However, the paradox is, this seemingly empty state, full of unlimited potential, just like a blank canvas waiting for the painter to express his creativity. Then in this vast nothingness, is there some kind of power quietly surging? Perhaps it is a kind of restlessness that breaks the static state, a force that surges secretly in silence. In the depths of silence, maybe there are sparks that have not yet been realized, a mysterious opportunity that can ignite the fire of the universe. Everything comes from nothing. Is this nothingness really nothing? If this nothingness itself contains the seeds of creation, then it is undoubtedly the quiet prelude to a magnificent symphony. And when that mysterious spark really ignites, he will trigger a cosmic creation, bringing the past and everything that will last forever. To solve this puzzle, we must go deep into the silent, exploring the core of emptiness. From the perspective of classical physics, look at the existence of the universe itself. It is full of paradoxes, how to create something out of nothing. For hundreds of years, the laws of physics we know, they are all based on cause and effect, action and reaction, on the laws between matter and energy. Proposed a view that the universe could have been created out of nothing. It sounds like magic, but it is this problem, for a long time, has been challenging countless thinkers and scientists. Let them continue to explore the origins of everything around us. Throughout most of human history, the question of the origin of the universe has always been classified as philosophy and theology. Until the 17th century, the emergence of classical physics represented by Newton, it has built a description of the nature of the universe for us. Movement rules, and a theoretical framework that sustains the structure. Newton's theory reveals such a phenomenon. Every particle in the universe interacts with each other. The sun's gravity keeps the planets in orbit. The Earth's gravity keeps us standing. However, these laws, all built on a universe that already exists, a world full of stars, planets, and vast space. For all these substances and energies, how is it born? But keep silent. As physics continues to advance, questions about the origin of the universe remain. Although, this field seems to have been difficult to give a definite answer. According to the concept of classical physics, every event that happens, there must be a clear cause-effect relationship. Every action is accompanied by a reaction. If the universe suddenly appeared at a certain moment, so what is the reason for it to exist? Even more puzzling is, where do the matter and energy that make up the universe come from? This is the dilemma facing classical physics. According to the law of conservation of energy and matter, matter and energy do not come into being out of nothing. It won't disappear completely. They just keep changing their form. From this perspective, classical physics seems to deny the possibility of a universe emerging from true nothingness, because this law implies that the universe has always existed in some form, no real beginning or end. Although this view may be reassuring to some people, but he didn't answer the deeper question. questions about the nature of existence. With the advent of the 19th century, the picture of the universe begins to change. Classical physics is also facing unprecedented challenges. The rise of thermodynamics brought the concept of quotient, used to measure the degree of disorder in a system. Although energy does not come out of thin air, it won't disappear completely, but its availability for workmanship is decreasing. This leads to the theory of heat extinction of the universe. In the distant future, all available energy will be depleted. The universe will eventually reach the state of maximum quotient. However, this doomsday scenario, compared with the static state described in Newton's time, the eternal universe is completely different. It seems that the universe is evolving in a certain direction, but its origins remain shrouded in mystery. In this context, some physicists began to explore the nature of the origin of the universe. If the universe is not eternal, there is an endpoint. So does it also have to have a starting point? This starting point, how to achieve the transformation from nothing to something. To solve this mystery, some scholars have proposed the concept of space bombs, a primitive state. It contains all the matter and energy in the universe, all compressed into a single point. Although the state is not absolute nothingness, but he has a finite starting point for understanding the universe. Provides a possible approach. Perhaps all matter and energy. Everything was once concentrated in this infinitely small point. From it was born the whole universe. The universe is not completely impossible. Here, classical physics seems to be at a crossroads. On the one hand, he sought strict laws of motion and cause and effect. Every result has a clear cause. The existence of the universe seems to challenge these laws, as if I were the biggest exception. Therefore, although classical physics cannot ultimately explain how the universe came from nothing, but he laid a solid foundation for subsequent exploration. It also paved the way for the emergence of new theories in the 20th century, those that reveal more about the complexity of the universe. The search for a theory of the origin of everything, emerging, and inspire our curiosity about the unknown world. As science continues to advance, we gradually understand. Answer, not hidden in a grand and predictable realm, but in that place full of strangeness. The counterintuitive microscopic world. It is in the field of quantum physics that a whole new frontier emerges. Particles can be in an uncertain state. All stories about the origin of the universe will therefore be rewritten before the Big Bang. According to the classic definition, we might call it nothingness. But quantum physics, it tells us a completely different story, a more detailed story. In this story, nothingness is not simply emptiness or dead silence. At the quantum level, it is a vibrant melting pot, a boiling ocean of potential. Thorough, subverting our traditional understanding of existence and nothingness. It is in this quantum void we found the origin of all things. The universe is about to open the stage for life, different from the classical, that absolutely empty space. The quantum vacuum is not nothing. Physicists such as Paul Dirac and Richard Feynman, through their quantum electrodynamics, pioneering research in the field of, revealed a shocking fact. Even in a seemingly perfect vacuum, we thought we would see complete emptiness. There's actually a continuous activity, virtual particles, constantly flickering between existence and non-existence. It seems to appear out of nothing and then disappear in an instant. They follow the unique rules of the quantum world, dancing a wonderful dance. So strictly speaking, the quantum vacuum is not really nothing, but a vibrant, restless ocean. There is endless potential. Quantum electrodynamics, Let's delve deeper into the subatomic world. They're the familiar laws of classical physics, by those seemingly absurd, but it is replaced by real quantum phenomena. At the heart of quantum electrodynamics, a vacuum is not absolute emptiness. Instead, there are quantum fluctuations and virtual particle pairs, like positive and negative electrons constantly emerging and annihilating, and regulated by photon exchange, various interactions. These elementary particles of light, this strange and vivid dance, quantum electrodynamics, it flourished in the mid-20th century. This is mainly due to Richard Feynman Julian's, Wenger and Tomonaga, pioneering work by physicists such as Shinichiro. They built on the earlier ideas of Paul Dirac. This theory was further developed. This equation not only successfully explains the properties of electrons, he also predicted the positron, also known as the existence of anti-electrons. First hint of vacuum or nothingness, not just a void. Quantum electrodynamics mainly describes such as electrons and positrons, interaction with electromagnetic fields. In this theoretical framework, interactions between particles, not transmitted via continuous fields. It is achieved by the exchange of quantum photons. Unlike electrons, photons travel at the speed of light. And this exchange, it comes in the form of discrete packets of energy, rather than the continuous action in classical physics. Imagine, two electrons repel each other in the quantum world. This repulsive force, it is due to the relay race between them was almost instantaneous, constantly exchanging countless virtual photons that are not directly observable. These virtual photons only exist briefly under the rules of quantum mechanics. Their exchange, the essence of electromagnetic interaction between electrons. This is also the case with quantum electrodynamics, where the strange properties of the quantum vacuum begin to be revealed. According to the theory, even in the space we perceive as empty, various virtual photons and other types of virtual particles is constantly being created and destroyed. Feynman diagrams provide us with a way to visually display this complex interaction. It is more than just a graphical representation. It is an abbreviation that condenses complex mathematical expressions, describes the particles, all possible interactions. In these figures, every interaction, all contribute to the probability amplitude of the overall process. The squares of these amplitudes, this corresponds exactly to the experiment, the probability of observing a specific outcome. The concept of virtual particles. This is the core of quantum electrodynamics. Unlike real particles, virtual particles does not strictly follow conventional conservation laws, as long as they are in a very short time, returning borrowed energy. It does not violate the Heisenberg uncertainty principle. This principle not only reveals the position and momentum of particles, complementary relationship between measurements, it is also allowed to. A brief energy violation occurs, thereby allowing virtual particles to exist briefly in a vacuum, without being directly detected. Therefore, the quantum vacuum is actually a seething mass of activity. Field particles are constantly generated and disappearing in it, showing a state far from air or calm. One of the fascinating phenomena is the vacuum project. Imagine, the vacuum is a vast ocean of virtual particles. When a real charged particle, for example, when an electron is placed, it interacts with the virtual particles around it. Virtual positrons near real electrons. They will be attracted slightly closer by the negative charge. The virtual electrons are repelled and move slightly away from. This creates a virtual charge cloud around the electron. This layer of charge cloud, effectively shielding the electric field of electrons at long distances. In a very short distance, the electric field strength of electrons appears to be stronger. In fact, this effect, it has been experimentally measured with extremely high precision. Got verified. Sometimes the accuracy is even up to a dozen decimal places. This fully confirms the predictions of quantum electrodynamics. Besides, quantum electrodynamics, it also gives us a better understanding of the quantum field itself, a deeper understanding. In classical physics, fields such as electromagnetic fields, considered as a continuous smooth, entities that are spread throughout space. At the quantum level, these fields are actually composed of countless tiny, discrete interactions. It is through these quantum interactions that we recognize even this seemingly empty vacuum. There are always endless activities and possibilities. The quantum vacuum is like a turbulent ocean, full of virtual particles that constantly emerge and disappear. With fluctuation, this phenomenon directly leads to the concept of zero-point energy and its profound impact on the nature of reality. Zero-point energy refers to a quantum system, the lowest energy state that can be achieved, even at absolute zero. In theory, all classical thermal motion should stop completely. But quantum mechanics tells us, even in this extreme state, the system still retains some energy that cannot be eliminated. The presence of this energy, inherent uncertainty in quantum mechanics. In particular, Heisenberg's uncertainty principle. It limits us. Simultaneous and precise determination of particle position and momentum. This forces the particle to. There will also be small but persistent energy fluctuations. To understand this more intuitively, consider a simple pendulum clock. Without external interference, the pendulum will eventually settle into its lowest energy state. Kinetic energy is completely zeroed. However, in the quantum world, corresponding to the quantum oscillator even in the ground state, there will also be slight vibrations. This vibration, not caused by any external heat or force. Rather, it is a direct manifestation of the intrinsic quantum properties of particles. To make the oscillator reach the zero energy state, it is necessary to accurately determine both its position and momentum. This violates the uncertainty principle. Therefore, there's always some residual energy and zero-point energy. This concept applies not only to individual particles. It extends to the essence of the entire space. In quantum field theory, every point in space corresponds to a field, and these fields are constantly affected by quantum mastery, even without any actual particles, or in the presence of classical electromagnetic waves. For example, electromagnetic fields, still vibrating, zero-point energy. It is this vibration, make virtual particles in a vacuum, randomly appearing and disappearing. This zero-point energy is not just a theoretical conjecture. It has observable physical consequences. The most famous example of this is the Casimir effect. 1948 physicist Hendrik Casimir, Philips Research Laboratory in the Netherlands, when studying quantum phenomena. Notice this, a phenomenon, even a completely emptied, all particles in the ideal vacuum field. It also contains an irremovable minimum energy. Casimir's idea, place two parallel metal plates very close together, but no contact, according to the expectations of classical physics. In a perfect vacuum, these are not powered. There should be no force between the non-magnetic plates. The board should remain stationary. However, quantum field theory tells us a vacuum isn't really empty. It is a volatile, a sea of virtual particles and electromagnetic fields. These fluctuations, produces zero-point energy throughout space. Casimir reasoned further, because space places certain restrictions on the wavelength of virtual photons, similar to only certain notes, can have the same name in a box of a specified size. Between the two boards, fewer electromagnetic modes are allowed than in outer space. Such model differences. This causes the density of zero-point energy outside the plate to be higher than that inside the plate. This creates a tiny gap between the boards. But measurable attraction. The force Casimir calculated is very weak, only visible at a distance scale of about 1/1 meter. Later in the late 1950s and 1960s, scientists conducted a series of complex experiments. This effect was gradually verified. By 1990, Steve at the University of Washington, Lamoureux has an accuracy of about 5%, highly precise measurement of the Casimir force. This strongly confirms Casimir's prediction. Experimental design, by placing a flat plate near a sphere, can be avoided as much as possible when aligning two perfectly parallel plates. Technical difficulties encountered. It is this precise measurement. Casimir's weak attraction was confirmed. This proves zero-point energy is more than just a mathematical artifact. It is a real physical phenomenon. In classical physics, we usually think of space as empty. There is indeed nothing. However, from a quantum perspective, even the purest vacuum, it is also filled with a constantly vibrating field and the creation and annihilation of virtual particles. That's why the concept of zero-point energy. This is particularly important when discussing the origin of the universe. It makes us realize the vacuum is not an inert, empty stage. It is a dynamic and energetic structure. To explore how the universe came into being from nothing, opening up new possibilities. In this quantum melting pot, strong fluctuations often occur, more than just a faint ripple of energy. It's the process that actually produces particles and antiparticles. For example, quantum fluctuations can give birth to a pair of particles and antiparticles. For example, an electron and its corresponding positron. After their brief appearance, it was quickly annihilated in the explosion of energy, returned to the void that gave birth to them. This phenomenon is not accidental. It is happening all the time in the whole space. If we could peer directly into this quantum world, what comes into view? It will not be a peaceful void. It's more like a layer of boiling foam. Time and space are like a pot of boiling soup, full of constant changes, bending and twisting foam-like structures, driven by these countless quantum events. In this bubble, it may even give rise to truly extraordinary phenomena. I just want a particularly strong fluctuation, sufficient to last, won't dissipate immediately. Instead, it may become the seed of some real existence. According to the strange logic of quantum mechanics, even a wave in a vacuum, as long as its strength is sufficient, it may also give rise to a whole new field. There, energy and matter began to gradually gather. This is the quantum layer, the starting point of the transformation from nothing to something. Just like the quantum vacuum is full of energy and infinite potential, become a melting pot that breeds a new universe. So, how did this all happen? What makes those ever-changing fluctuations transformed into the first tangible echo of existence? To answer this question, we must delve into the nature of time. Before the universe was born, the concept of time is actually meaningless, because the time we know originated from the structure of space itself. In that fluctuating quantum realm, there is no past. There is no future. There is no linear time series. With the birth of the universe, A universe born from quantum fluctuations. Appear quietly. Time. The faint whispers at first began to echo in it. The smallest unit of time is Planck time. Approximately minus 43 seconds. Marks the first time slice we can measure. It is also our ability to understand. The moment when things start to get out of control. In this very brief moment, the universe is compressed to an unimaginable size, hotness, and density. Formed a world with infinite energy. The starting point of infinite possibilities. It is in this quantum uncertainty that an area is dominated by extremely high density. The time we perceive begins to flow. At the same time, the laws of nature govern. Fundamental forces and laws that define cosmological constants. It is also gradually established in this chaos. This quantum bubble is full of foam potential. More than just a sea of randomness. It is also a fertile soil that breeds time and space. At this moment, the event we now call the Big Bang, it wasn't a violent explosion in space. The space itself, from a starting point born from quantum fluctuations, rapidly expanding. Ironically, this seemingly nothing starting point, but in a mysterious and elusive way, presented before us. Planck time. It not only marks our measurement of the origin of the universe, the limit of ability, more like a mysterious curtain, covered. That reality has not yet appeared in any recognizable form. Early history. At this early stage, the concept of the quantum world comes into play. That is to say, at some point, a key quantum event or fluctuation. It may lead to the birth of the entire universe. Cosmologist Alexander Vilenkin proposed this idea. Hint of the universe, maybe spontaneously, emerging from the fluctuations of the quantum vacuum. This fluctuation, with us in virtual particle phenomena, similar observations, in a subtle way, reflected in the basic structure of space. By Vilenkin, further development of quantum tunneling out of nothing. Theory holds that our universe, maybe through something like quantum tunneling, born from the process of wearing, that is, allowing particles to crossing those impossible energy barrier. Let's understand this phenomenon with an example. Imagine you're playing basketball in your backyard, between the yard and the neighbor's yard. A wooden fence. In classical physics, if you throw the ball towards the fence, since the ball does not have enough energy to pass through the obstacle, it will bounce back. However, in the quantum world, the situation seems very strange. Think of the ball as a small particle like an electron, and think of the fence as a potential barrier. Even if the electron does not have enough energy to climb over the obstacle, there is still a small probability that go through the other side of the tunnel obstacle, just like the ball occasionally appears magically in the neighbor's yard. This phenomenon is called quantum tunneling. The quantum world is full of this puzzling surprises here. All the seemingly impossible events have a non-zero probability of occurrence. This is the essence of quantum mechanics. According to this view, the universe may also work in a similar way, out of absolute nothingness. In other words, the birth of the universe does not rely on a specific causal relationship or preset conditions. It's because at the quantum level, nothingness itself is not really nothingness. It is a state of potential, can give birth to things. However, to make this universe born, evolved into the vast world we see today, some dramatic events need to happen. Perhaps only tiny quantum fluctuations. This triggers a series of key processes. The universe rapidly expands to a macroscopic size. Scaling symmetry breaking and cosmic expansion. It is in this process that helps to convert the initial quantum fluctuations, transformed into a macroscopic, tangible universe. Theory of the expanding universe. Originally developed by MIT physicist Alan Guth proposed in 1980. He tried to solve the standard. Some thorny contradictions in the Big Bang model, especially the issue of world peace and washing. The world's problems stem from the fact that some regions of the universe are too far apart. According to classical theory, they can't communicate with each other at all, but their temperatures are almost exactly the same. The problem with flatness is that the observed universe, it seems to be between expansion and gravitational collapse, a delicate balance. These phenomena suggest something big must have happened in the early universe. This makes the universe appear so even and balanced. State of Guth's breakthrough insights from particle physics. This seemingly unrelated field, he realized, early universe may have experienced phase transition similar to water freezing. This process releases enormous amounts of energy. This causes space to expand rapidly, triggered the so-called explosion. This explosion occurred in a very short period of time. The universe is expanding at an exponential rate, effectively smoothing out any initial quantum fluctuations. This also solves the problem in Guth's original model. Problems such as the explosion ending too suddenly. Guth's concept quickly sparked a lot of research and gradually improved, making inflation theory the core of modern cosmology. Andrew, a Russian physicist at Stanford University, Linda further expanded on Guth's work. He proposed a new expansion model. Then the chaotic expansion theory was developed. These models, problems with Guth's original theory, provide solutions, and it shows the inflation phenomenon under more relaxed initial conditions, spontaneous occurrence, without having to be too elaborate a starting point. In particular, the chaotic expansion theory proposes the expansion of the universe can be derived from high-energy fields. Quantum mastery emerges by accident, then naturally born out of nothing. The core idea is that in the earliest moments of the universe, a strong energy field called the expansion field dominated the universe. As the energy gradually decreases, it triggered a rapid exponential expansion of space. The vast universe we see today, laying the foundation. Expansion is more than just a simple stretch of the existing space. It also marks the true birth of space and time. Before the expansion, according to modern theory, the universe exists in a state without a clear space-time structure. A starting point, an infinitely small point. There the density and temperature reach infinity. The traditional concepts of space and time. It also melts away. According to Einstein's general theory of relativity, this starting point means our traditional physics understanding. The end, however, quantum mechanics. It provides a whole new perspective on all of this. Even though this starting point, in a classic sense, it seems to be the starting point of everything, it may also simply represent the state of quantum potential, a bubble of possibilities. From this, perhaps time and space can be born. In the subsequent expansion phase, this quantum foam undergoes a phase transition. This eventually led to the birth of space and time. The expansion field that permeated the early universe at that time. It is believed to contain huge potential energy. As this energy gradually decays, it converts into kinetic energy. This triggered a rapid exponential expansion. This expansion not only calmed down the initial quantum fluctuations, more importantly, he turned these tiny fluctuations, expanded to the entire universe, sowed the seeds for the distribution of matter. Is these seeds Eventually, they gathered together under the influence of gravity, evolved into the galaxies we see today, stars and planets. Therefore, the universe expands. Not only does it shape the macro structures we see, it also builds the quantum field, a bridge to the classical world. Stephen Hawking and James Hartle. The no-boundary hypothesis was proposed in the 1980s. This is a vivid embodiment of this concept. This hypothesis suggests the universe does not have a clear beginning or time boundary. Before the beginning, there was nothing. On the contrary, time itself gradually becomes a dimension of space under extreme conditions. For example, the earliest moments of the universe. The boundaries between time and space become blurred. The time we know, it was in this process that it gradually emerged. In their opinion, the universe is self-contained and has no boundaries. This means that it may have originated in a pure state. There is no clear starting point in the traditional sense. Rapid cosmic expansion in space-time. It plays a vital role in the birth process. It effectively converts time from that starting point filled with the fog of quantum gravity. Liberate. Before the expansion, due to the lack of space concept, time doesn't pass the way we're used to. However, as the expansion unfolds, a space-time object with a clear structure gradually takes shape. The initial quantum fluctuations are also stretched. This laid the foundation for the development of time. This profound concept reminds us, the time we experience, it may come from the spontaneous decay of quantum fields, an event that triggers the spawning of the vast space. It also gives direction to the arrow of time. As the energy of the expansion field decays, the huge energy released cools down quickly and transformed into elementary particles. These particles, eventually, this form the universe we see today. The transition from quantum to classical reality, the evolution from uncertainty to certainty, can be seen as a natural consequence of the expansion of the universe. Quantum mechanics tells us particles can spontaneously shuttle between existence and non-existence, frequent creation and destruction. This quantum fluctuation, not only does it indicate the chaotic state of the microscopic world, also for the birth of the universe, provides a physical basis, rather than just a philosophical idea. Theory of the expanding universe. It was developed on the basis of this idea. He believed that the universe originated from fluctuations in quantum fields. Through exponential expansion, this formed the space-time structure we know today. In other words, the universe did not exist in a given form, but in the process of expansion, gradually amplify the initial quantum fluctuations, eventually evolved into macroscopic space and time. This theory not only has profound theoretical connotations, this is also strongly supported by experimental data. Observations of the cosmic microwave background radiation and the afterglow of the Big Bang provides us with a snapshot of about 380,000 years. Some of the tiny temperature fluctuations considered as an early expansion process, the mark of the quantum long fall. Precision experiments, such as those conducted by the Planck satellite. These temperature changes have been successfully mapped. This confirms many of the predictions of inflation theory. Let's see directly the first moments of the universe. So from a perspective of quantum explosion, the birth of spacetime can be viewed as a function of infinite possible quantum states. Toward destructured, the process of transition in the expanding universe. Inflation theory, not only is time and space born from the starting point, provides the necessary conditions and the basic laws of quantum mechanics. Description of spacetime with general relativity, organically combined. This combination not only does the concept of the creation of the universe out of nothing become imaginable, it also revealed between microscopic quantum phenomena and macroscopic cosmic structure, there is a deep and inseparable interconnection. The universe, as we understand it, in fact, it is the manifestation of quantum fluctuations after being amplified. It is caused by expansion, stretching and shaping quantum field edges. A grand picture woven. This is where everything we know started. If Bang theory could reveal tiny quantum fluctuations, give birth to a universe, this could well imply that there are countless other universes. They may also originate from quantum fields. The unique seed in the infinite field may be our universe, just a piece of the puzzle in this infinite tapestry. Every universe is expanding and has its own unique physical laws constants and a unique destiny. In the strange realm of quantum mechanics, particles can be in multiple states at the same time. Reality therefore seems fuzzy and full of variables. From countless possibilities, suddenly a universe that must exist was born. This is the core starting point of the multiverse hypothesis. This idea, pushing the implications of quantum theory to its limits. If our universe, it really comes from boiling, a quantum fluctuation in the vacuum. So, what reason is there to prevent the birth of countless other universes? Each universe may have unique properties, independent space-time dimension, their starting points. It may even herald the end of their unique. To understand this, we must first explore the concept of eternal expansion proposed by Linda in 1981. We have discussed Alan before. Goose's primordial inflation theory. This theory provides answers to many puzzles about the early universe. For example, the smoothness and uniformity of the universe provide an explanation. After the Big Bang, a rapid exponential expansion of space occurs immediately. However, Linda takes this concept a step further. His theory of eternal expansion. Not only did it solve cosmological problems left in the model, there's also an infinite multiverse that may exist. Open the door. According to Lind, under the basic principles of quantum mechanics, countless universes may each emerge from quantum fluctuations. This idea originated from a more detailed look at the expansion process itself. In Gus's model, universe expansion seen as a one-time event, a briefly excited explosion field, rapidly pushing the universe outward. Make it smooth, and lay the foundation for the future evolution of a universe. But Lind doesn't see the explosion as a single event. Rather, it is a continuous and eternal process. The core of this theory, to reveal the nature of quantum fields and the inherent randomness of quantum mechanics. In quantum field theory, every field, including the disaster area, influenced by quantum mastery, even in a seemingly empty space, there will also be small random fluctuations. It is these quantum fluctuations. This causes random changes in reimbursement in different areas. In some areas, the factory value may decrease. This causes the expansion to stop. For like us, a universe with conventional space and time. Time begins to unfold. In other areas, the value of this field remains high. The surge continues. Make these regions expand faster than the speed of light. This continuous expansion process creates a dynamic pattern. Some regions are slowing down their expansion and evolved into an independent pocket universe. The other areas expand infinitely. Linda's theory thus changes our understanding of the universe from a single isolated universe, transformed into an infinitely diverse system. a collection of countless pocket universes. Each universe, all formed one after another in a background of eternal expansion. This process, similar to the ever-expanding space, an endless chain reaction. Some areas gradually became independent islands, just like our universe was born. In other areas, the explosion continues, giving birth to more and more unique bubble universes. Julian, Barbara spent a lot of time exploring the nature of time, provides a fascinating perspective involving the concepts of time and the entangled multiverse. He challenged the traditional, view time as a flowing river concept. Instead, we believe that time is composed of a series of discrete, every moment that makes up this moment. They are all independent and unique in his model of eternal reality, past and future, just an illusion created by our perception. Only the present moment is real. This view coincides with the characteristics of the quantum world. In quantum mechanics, before the particle is observed, does not have definite properties. The act of measurement collapses the wave function. Select a specific state. This makes the position or velocity of the particle clear. Barber believes every present moment is like a snapshot of the universe, is an independent quantum state. If we take this idea, expanding to the multiverse, every moment, each of them may correspond to an independent bubble. The universe at every moment. They all seem to be woven red, a unique clue in the tapestry of the universe. These clues, and through the secret connection of quantum entanglement, intertwined. This possibility, this has also been shown in the research of other physicists. They proposed, time itself may be an emergent phenomenon. It's a byproduct of quantum entanglement. For example, Carlo Rossi, an authority in the field of quantum gravity, Willie thinks the time we perceive is not a fundamental entity, but it is caused by the differences between different quantum systems, the changing relationship defined. From this perspective, in the context of the multiverse, the flow of time, it may even vary between universes. It depends on the inside of each bubble. Unique configurations of quantum fields and particles. If time is truly an emergent phenomenon, the multiverse, again, a series of entangled quantum states. So, our understanding of reality becomes more fluid and are interrelated. The fate of different universes, maybe through quantum entanglement, the subtle and mysterious clue, mutual influence, like being in an infinite cosmic cave, ripples that keep echoing. This raises a deeper question. The laws of physics in every universe. Is it possible that they are different? Perhaps every universe. All of them are caused by the specific quantum entanglement inside them. Shaped, if that's the case. So, is it possible to use quantum entanglement? The strange property of non-locality. In these distant universes, conduct some form of detection, even communication, although these issues are still at the speculative stage. But we are at the forefront of pushing the boundaries of our understanding. On theory, as we continue to explore, maybe you will find the source of the entire multiverse, more interconnected and mysterious than we thought. Like a picture made of quantum lines of reality. A magnificent picture of interweaving. If the quantum multiverse, suggesting an infinitely vast cosmic landscape, then each universe, born like a spark from the cosmic fire. This forces us to think. What ignited these sparks? What drives them? Erupting from the depths of nothingness. To answer these questions, we must delve into the nature of existence, enter the mysterious and murky world of particle physics. As discussed earlier, reality itself is woven from the most basic threads, The concept of multiplicity, constantly challenging our traditional understanding of reality. To truly understand this confusing idea, why is it proposed? We must return to the smallest possible scale. That is, the world of particles and fields. In quantum cosmology, the birth of the universe is often described by probability. Different quantum states may produce different cosmic outcomes. This method, it is built on the foundation of particle physics. Particle physics research is the most basic building block of nature, and their interactions, a crucial moment in the early days of the universe. Higgs, the field has become one of the most important participants. Higgs field as an omnipresent energy field, filling every part of the universe. Imagine a corner. Infancy after the Big Bang. The universe lasted only a few seconds. The environment was extremely hot. Dense particles are massless. They are traveling at the speed of light, unable to aggregate into the stars that later formed planets, even the substance of life. And it was the emergence of the Higgs field that changed all that. The Higgs field provides mass to particles. No Higgs field, everything in the universe will lose mass. Matter as we know it would not exist. To better understand the role of the Higgs field, compare it to thick syrup or sugar water. When a particle travels through this field, it's like moving in a glass of thick liquid. They have to push away the surrounding medium, thus interacting with the Higgs field. In this process, the particle gains mass. The stronger the interaction with the Higgs field, the greater the resistance the particles encounter when pushing the medium away. It is also heavier. Not all particles all interact with the Higgs field in the same way. For example, photons, as particles of light, does not interact with the Higgs field at all. Therefore, they always remain massless. And particles like quarks and electrons, strong interaction with the Higgs field, thus obtaining quality. An intuitive analogy is, imagine you are walking in an empty room, can move quickly and easily, like a massless particle. But if the room is full, you'll be hindered at every step, like you need to put more effort, navigating the crowds. The resistance here, it is similar to the effect of the Higgs field on particles. The more crowded the room, that is, the stronger the interaction, the harder it is for you to move forward. The particle gains more mass. Through this layer of explanation, we can see, early in the universe, those seemingly random quantum fluctuations and the existence of the Higgs field, together for what we see today, the foundation of a structured universe. If there is no Higgs field, playing a role similar to cosmic syrup, the particle will remain in a massless state. High-speed movement can never condense into atoms or molecules. The universe we know would not have formed. However, this process was not obvious at first. In fact, the existence of the Higgs field, one of the greatest mysteries in physics. Until 2012, the discovery of the Higgs boson was confirmed. Higgs bosons are particles associated with the Higgs field. Its discovery was a groundbreaking achievement. Particle physics verified, a key part of the Standard Model. It also explains the basic structure of the universe, how blocks interact with each other. Theoretical framework provided. To understand the significance of the Higgs field, we have to place it in the broader Standard Model. Background over the past few decades. This model was created by Hilton Glashow-Abdo, Salam and Stephen Weinberg, some of the best minds in physics, including, developed together. Standard Model represents humanity's efforts to study the most fundamental particles in nature. Crystal. He described in detail all the known particles. For example, the quarks that make up protons and neutrons, lepton like electron, and meson particles that transmit force. such as photons and gluons. These particles do not exist in isolation. They interact through four fundamental forces: gravity, electromagnetic force, weak nuclear force, and strong nuclear force. Each force controls a different aspect of the universe, from maintaining the stability of atomic nuclei to generating electromagnetic radiation, like the process of light. These basic forces are inseparable of the four fundamental forces. The Standard Model explains the electromagnetic force and weak force, and strong synergy have achieved amazing success. The electromagnetic force is described by quantum electrodynamics, successfully explain the phenomena of light and electricity. If the combined force governs radioactive decay, strong combined force, the atomic nuclei are stably condensed together. However, we can unify our understanding of the world. One of the biggest challenges is gravity. Gravity governs not only the planets, the motion of stars and galaxies. It also gives weight to objects on Earth, but it is conspicuously missing from the Standard Model. The Standard Model mainly describes the quantum world and particles and interactions at the smallest scales. Gravity. This is explained by Einstein's theory of general relativity, the large-scale structure of the universe. Integrate these two sets of theories into a single framework, the so-called theory of everything. It has always been regarded as the ultimate goal of physics. In this context, the Higgs field. It is particularly eye-catching because he revealed step by step how particles acquire mass, and it implies that there is a connection between the quantum world and the macroscopic universe. There is a deeper connection. Discovery of the Higgs boson provides decisive evidence for the existence of the Higgs field. This is not only for particles. Strong confirmation of the Standard Model of physics. It also helps us understand the basic structure of matter, opening up new avenues. Although, detecting the Higgs boson is fraught with challenges. But this breakthrough, it undoubtedly makes us closer to understand the unified connection between all things in the universe. To find the Higgs boson, scientists need to be in the laboratory, reconstructing the extremely high energy conditions of the early universe. Jura. This is where the Large Hadron Collider comes in handy. CERN in Geneva, Switzerland, home to the world's largest and most powerful particle accelerator. The LHC can add protons near the speed of light, then let them collide violently, release huge energy instantly. This simulates the Big Bang, the extreme physical conditions, allowing scientists to observe particles that cannot be produced in everyday environments. In 2012, after years of high-energy collision experiments, post-calculation researchers announced discovery of a new particle, the Higgs boson. The discovery, hailed as one of the greatest scientific achievements of the 21st century. It not only confirms the existence of the Higgs field, to explain how particles acquire mass, provides key answers. It has also been proven over the past decades. Theoretical predictions based on the Standard Model. Discovery of the Higgs boson. We understand the universe, a milestone in basic construction. But this is by no means the end, more like a stepping stone, guiding us towards more ambitious goals. Build a theory that explains the entire structure of reality. However, although the Higgs field is successful, explains how particles gain mass, but doesn't solve all problems. One of the biggest unsolved mysteries, gravity. Gravity governs planets and stars, even the movement of the entire galaxy. It is what holds the macrocosm together. But this part is missing from the Standard Model. That's why physicists turn to grand unified theories, the two frameworks of harmony theory We hope to make up for the shortcomings of the Standard Model. Let's get closer. The ultimate goal of achieving a theory of everything. The idea of a unified fundamental force did not come out of thin air. Its history can be traced back to the late 19th century. Maxwell successfully combined electricity and magnetism, unified into a single theory of electromagnetism. This breakthrough sets a precedent for us, indicates the various forces in the universe. In fact, they're the same basic, different manifestations of reality. It is this thought that inspired later physicists. Fast forward to the 20th century. At that time, like Hilden, physicists like Glashow develop a theory, successfully combine the remaining two forces. Unification of the electromagnetic force and the weak nuclear force. This theory is called the electroweak theory. This shows that under extremely high energy conditions in the early universe, electromagnetic force and weak force once merged into a single unified force. This is not only a huge leap, it also laid the foundation for the later Standard Model. However, the ultimate goal of unifying all fundamental interactions, still out of reach. This is where grand unified theories come into play. Grand unified theories attempt to go one step further, combining the electroweak force with the strong force. According to this theory, in the extremely high energy state of the early universe, electromagnetic force, the weak and strong nuclear forces were once a single, unified interaction. Only as the universe expands and cools, these forces gradually differentiated into what we observe today, independent forms. Physicists have discovered a new theory of the Great Unity, using complex mathematical equations to describe high-energy symmetries and predict that far beyond the current, at the energy scale that particle accelerators can reach, strong and weak core, electromagnetic force will behave as a unified force. This means, if the future can build a particle accelerator powerful enough to reconstruct the conditions in the early universe, we may. This unification phenomenon can be directly observed. However, the energy levels we can currently achieve, for example, the energy of the Large Hadron Collider, still far below the scale needed to test grand unified theories. Also, grand unified theories also make some bold predictions. One of them is proton decay. Many theoretical model languages, protons as the building blocks of the atomic nucleus, over extremely long time scales. If the decay phenomenon can be observed, it will become important evidence for the grand unified theory of knowledge. Unfortunately, although scientists have searched for decades, but no clear proton decay signal has been found so far. This makes the grand unified theory still in a hopeful. However, it has not yet been directly verified. It should be noted that grand unified theories are primarily devoted to unifying the three quantum forces in the Standard Model: electromagnetic force, weak force, and strong force. And he still can't explain gravity, the fundamental interaction. Gravity governs planets and stars, even the macroscopic structure of the entire universe. In the Standard Model, gravity has never been included in its unified framework. That's why physicists turn to string theory, trying to achieve unity at a deeper level. String theory not only seeks to unify the electromagnetic force, weak and strong forces, we also try to include gravity, overcoming gravity and other forces, fundamental differences in description, a bigger step towards a theory of everything. The Standard Model is based on quantum mechanics, mainly process particles, and their interactions at extremely small scales. On the other hand, Gravity depends on Einstein's theory of general relativity. It is good at describing planets. The motion laws of macroscopic celestial bodies, such as stars and galaxies. But it is difficult to apply at the micro level. This quantum mechanics. Fundamental incompatibility with general relativity. Always considered one of the deepest mysteries of modern physics. String theory provides a solution to this problem. A possible solution is provided. He put forward a radical view, no longer seeing particles as tiny dots, but as a tiny vibrating string. In the framework of string theory, all elementary particles, whether it is quarks, electrons, photons, or the Higgs boson, in fact, they're made of extremely small strings, expressed in different vibration modes. The scale of these strings, much smaller than any matter we can currently observe directly. It is their own unique way of vibration, determines the various properties of the particles we see. For example, a string's vibration mode. It may correspond to an electron. Another vibration mode. It may represent a quark. The charm of string theory lies in it naturally incorporates gravity into the unified framework. In this theory, there is a specific vibration mode that corresponds to the graviton. This particle is the medium that transmits gravity. This means string theory not only describes the part of quantum mechanical interaction, incorporating gravity into the mix. This provides a basis for describing all the forces in the universe and the particle theory of everything. This offers an attractive possibility. However, string theory is similar to the grand unified theory. A major challenge. The difficulty of experimental verification. The scale of strings in string theory is extremely small. At the Planck length scale, that is about -35 meters. Current technological means. It is not possible to directly detect such a small scale. This has led some critics to believe string theory is more like a mathematical construct, rather than a method that can be directly verified by experiment. Predictive physical theory. Despite these difficulties, string theory still unifies gravity, other fundamental forces of nature. Most popular, one of the most widely studied methods. To understand this possibility, we must learn from quantum physics. A basic concept to start with. Quantum fluctuation. According to quantum theory, we usually think of space as empty. It's not actually blank. In the field of quantum, nothing in the domain is completely static, or no activity. Instead, the vacuum is filled with temporary particles. These particles appear and disappear due to energy fluctuations. This phenomenon, it is often figuratively referred to as the ocean of quantum fluctuations, or quantum foam. This means, on the smallest scale, particle fields can instantly create particles out of nothing. Then it quickly disappeared without a trace. It is this mechanism of particle creation from nothing that forms the cornerstone of quantum cosmology. So how do we learn from this quantum mastery? Create a complete universe? Modern physics raises a surprising possibility. Under appropriate conditions, this quantum fluctuation can not only create particles, and it may produce the entire universe. A key idea is, the total energy of the universe may be exactly zero. That is to say, positive energy, such as matter and radiation. Energy corresponding to negative energy, such as gravitational field. In a sense, they can cancel each other out. Thus, the entire universe is energetically balanced. This is the spontaneous creation of a universe out of nothing. Provides theoretical possibility. This idea may seem counterintuitive at first. After all, a star filled with matter. The universe of galaxies and forces. How can the total energy be zero? The answer lies in a delicate balance between different types of energy. Matter and radiation contain positive energy. Gravity has negative energy. Because gravity causes objects to attract each other, this creates a negative energy. When all the positive energy is added to the negative energy of gravity, the total energy of the entire universe may be exactly zero. If that's the case, according to quantum mechanics, this universe, it is possible that the instantaneous, like virtual particles that are quickly annihilated, spontaneous birth from nothing, grand unified theory. Further support was obtained under the framework of. At the same time, it is also reflected in the theory of virtue. These theories, trying to describe the state of the universe at extremely high energies. This state, and the energy of the earliest moments after the Big Bang. The situation is very similar. Before this quantum fluctuation occurs, no substance, no energy, no space. There is no time, only one, governed by the strange rules of quantum mechanics. Quantum vacuum. These ideas may sound speculative, but they are rooted in the quantum principle that has been verified by decades of experiments. Quantum mastery. Symmetry-breaking interactions in grand unified theories, and the potential for extra dimensions in string theory. Together, they form a mutually complementary theoretical framework. In quantum physics, nothingness is not really emptiness. It is a state full of potential. An energy field, and various positions may appear at any time. It is in this context, particles can suddenly appear from nothing, then quickly disappeared. According to this view, under appropriate conditions, this quantum fluctuation, it may even give birth to a complete universe. This brings us to the core significance of the theory of cosmic expansion. After the Big Bang, the universe has undergone an extremely rapid exponential growth. Expansion. This process not only smooths out the initial small fluctuations, it also rapidly amplifies quantum fluctuations in the vacuum. This eventually led to what we see today, a vast and well-structured universe. The inflation theory states that, in the first few seconds after the Big Bang, the universe underwent a period of exponentially rapid expansion. This expansion, not only does it smooth out the possible any irregularity, and for subsequent galaxies and stars, and laid the foundation for the formation of planets. In other words, expansion provides a mechanism, explains how the universe could have, growing rapidly from tiny quantum fluctuations, and become stable, thus evolving into the vast universe we see today. In this view, the birth of the universe. This is not an isolated one-off incident. It's part of the natural behavior of quantum fields. The grand unified theory describes, in the extremely high energy state of the early universe, all fundamental forces, electromagnetic force, weak nuclear force, strong nuclear force, once unified into a single interaction. As the universe expands and cools, this state of unity, only then did it split into the different theories we see today. Theory of explicit. This provides a broader perspective on all of this. He not only seen as tiny lines of different vibration patterns, it also suggests that our universe, it may come from fluctuations in higher dimensions. As we stand on the edge of these profound ideas, you will find, if the grand unified theory of quantum mechanics and string theory could reveal to us the origin of the universe, so the same principle may also govern the future of the universe, even determine its end. That is to say, the quantum force that inspired the creation of the universe. It may not only create the universe from nothing, at some point in the future, lead him to the end. This all seems full of paradox. Because in our daily experience, nothingness seems to be absolute emptiness. However, quantum theory tells us vacuum is not really nothing. It is a dynamic instability, a place full of possibilities. In the quantum realm, particles can appear out of thin air and disappear just as quickly. This quantum fluctuation is the creation of the universe from nothing. The root cause of this miracle, if the quantum vacuum, full of ever-changing particles and virtual energy, it can even trigger fluctuations in the entire universe. We have to ask, was it really nothing, or the nature of quantum laws, so that some form of existence must appear? This is not just philosophical contemplation. It goes to the heart of our understanding of the universe. Quantum mechanics has shown us that reality is stranger than we think. It subverts the way we construct our time, the basic building blocks of space and matter. In the quantum realm, particles can be in multiple places at the same time, both exist and not exist, and presented in a way that goes beyond traditional understanding. Entanglement. This phenomenon even challenges our understanding of nothingness. In quantum mechanics, nothing is not an absolute blank. It's just a different state. It is the constant interweaving of existence and non-existence. Dancing background. If existence is indeed an inevitable consequence of quantum laws, then maybe nothingness isn't really nothingness. It is a real state, a canvas waiting to be painted by the universe. The quantum fluctuations that gave rise to our universe. It may not be a coincidence. It is an inherent characteristic of reality. In this sense, it may not be impossible for the universe to emerge from nothing. It is an inevitable consequence of quantum conditions, hidden beneath everything. Although we explored these possibilities, still facing a profound mystery. If quantum mechanics implies nothing is absolutely empty, can we get closer to understanding? Why does it exist? Is the universe just a random fluctuation? An unexpected product? Still, it suggests a deeper underlying structure. Maybe the quantum world holds the key to revealing the ultimate answer to existence. Or, this is just another step in our long journey of discovery. These thoughts continue to challenge the limits of our knowledge. Although quantum mechanics explains the interactions between particles, the subtle details of the effects and cosmic phenomena, a huge success, but there are still many problems. It is difficult to explain in a simple way. These mysteries are not only fascinating, it also inspires us to continue to explore the nature of reality. Maybe the time we perceive doesn't always flow in one direction. Space is not as solid as we think. Whenever we explore quantum mechanics, it always forces us to re-examine our existing assumptions, embrace the unpredictable in reality, and the paradoxical nature. So we are left with a tantalizing question. Is there really an absolute nothing? Or existence itself is part of the old quantum universe? What caused the explosion? This mystery still has no answer. Standing on the edge of these profound puzzles, we realize that the journey of exploration has just begun. The universe emerged from quantum fluctuations. Maybe it's just infinite. A chapter in the story is the quantum law that governs all existence, a proof of power and mystery, perhaps in the interweaving of nothing and something. The key to answering the oldest questions. Why is there, rather than absolute nothingness?